I'm the CEO at Emoshape. I'm also the architect of the emotion processing unit, so the first emotion chip for AI and robots.
Mm-hmm. And I think the thing that caught my attention when I saw the press release on the company at CES was, I guess, wanting to dig into a bit more about what this actually meant. And you claim to be the first EPU, the first emotional processing unit. And so I tend to deliver to a reasonably technical audience, so feel free to go into as much detail as you want. What do you actually mean by that? I mean, at the moment we tend to have CPUs, GPUs, sometimes audio processing units. Why is an EPU different from any of those?
Yeah, so the concept comes back to 2013. Actually, I was speaker at the TEDx conference at the Imperial College in London. Mm-hmm. I predicted that before the end of this century, human will talk more to intelligent machine than to other humans. Right. And if you think in terms of evolution, it's a huge shift. And I did that prediction before the buzz around AI or before product like Echo and the buzz around the robotics. And today it looks like this prediction could become a reality. The problem is that AI or robots are able to speak the way you speak and I speak. They're able to write articles. Even sometimes they say that they could replace even journalists in the future. Magenta from Google, the project Magenta from Google they are even able to write poetry. The problem is that the main difference between machine when they speak and human when they speak, it makes sense for you because the deep learning allows the machine to understand the structure of the language. But when you speak, it makes sense for me, but it makes also sense for you. What you say, you understand what you say. The problem today is that AI don't understand a word of what they say. Mm-hmm. And that's a big problem. I mean, I don't know if you remember the news 12 months ago, Microsoft created an AI called Tay, and this AI was tweeting horrible things about black people, feminists, Hitler, and things like that. And they had to take it down after 3 hours. They tried to put it back online 6 months later, and again, they had to take it down. Yeah. We saw that Facebook, for example, has an AI, and this AI, they had to take it down because it started to develop its own language. Because it was not able to understand the human language. Yeah. So all this shows that there is a real problem here. The other problem is that human and we're like very sophisticated machine. I don't know if you heard about the Maslow hierarchy of needs. Maslow states the needs of humans. The first one is food and security. I mean, if we are not fulfilled here very rapidly as machine, we stop working properly. Yeah. But we have also love, esteem, and self-actualization. Mm-hmm. If we are not fulfilled on these needs, it takes a little bit more time. But over time, as a machine, we will stop to work properly. Our productivity will fail, and our frustration will rise. Actually, it's more the opposite. Our frustration rise and our productivity fell. I'm going to give you an example. Crazy right now was able to make you extremely sad or angry, your problem, and you will not be able to be productive during the day. Mm-hmm. And so if in the future we spoke more to intelligent machines than to humans, and if these machines are not able to understand our emotional states because they don't have their own emotional states, over time, humans will build frustration, their productivity will fail, and we're going to reject the technology altogether. Okay.
So I guess then what the EPU then, it's not necessarily there to do the functions of the natural language processing, the all sorts of other sorts of current forms of artificial intelligence simulations that we have right now, but it's actually dedicated to processing other aspects of the interaction with the human that they're not really doing right now.
Yes, actually, a lot of research from the MIT and a lot other research institute was about how machine could detect human emotions. Mm-hmm. it's a fair game. I mean, it's so interesting, and people see a lot of possibilities here for selling and for advertising. So it's of course an interesting subject. But our angle was exactly the opposite.
Okay.
We turned the thing upside down.
Yeah.
We were not specifically interested in about how the human feel and how we can detect that, but we were interested in how the machine will feel based on how he interprets the world around him, and of course how humans interact with the machine. So emotional clues from human are important, but they are not the only one that will infer inside the emotional state of the machine. Mm-hmm. And so that's what the emotion processing unit is. It's a microchip that first, its primary function is to understand or feel high symbolic concept in the language. Mm-hmm. And the chip converts that into stimuli inside the chip. And these stimuli are represented in waveform. And we do wave computing. We're the only one in the world to do wave computing. So these waveforms are computed against each other. Mm-hmm. And the result is the emotional state of the machine itself. Mm-hmm. And of course, we can have a lot of different stimuli. So the main stimuli is the language, but you can have external layer that are connected to the chip that will give you information about the facial expression of the human, the tone of its voice, object recognition. So, for example, we took our chip, we put the chip inside the head of a robot, and we asked our robot to watch a movie.
Yeah, yeah.
So we couldn't do that in real time, but we were taking the robot, and what the robot could see, we were taking a snapshot in seconds. Mm-hmm. Back to Google. Google was sending us back what is seen in the image in text format. Mm-hmm. And this was appraised by the chip. And so the robot, for the first time watching a movie, started to get scared and disgusted when he saw bombs and explosion, and felt happy when he saw women and children.
Okay, yeah. All right. And sort of what level of detail can it get to at the moment? I see you've mentioned tracking 12 primary emotions: anger, fear, sadness, disgust, indifference, regret, surprise, anticipation, trust, confidence, desire, and joy. I mean, does it go into detail of, say, tracking eye movement, twitches in the face, or is it still kind of more like broad strokes of facial expressions?
This is not what we detect.
Okay.
This is not what we detect. One more time, we're doing emotion synthesis. I know that for humans it's difficult to accept the concept. It's not detection, it's how the machine feels itself.
Ah, right. Okay. Now I understand. So it's not actually it's...
No. We use some external layer for detecting human emotions.
Right. Okay. So then you
stimuli inside the chip.
Okay.
And the chip appraise and give emotional state for the machine itself.
Right. Okay.
So today, for example, imagine that you develop a robot, and if you most of the people who develop robot today, they hard code in the robot. Mm-hmm. Okay, if the user say this, my robot is going to reply that. Mm-hmm. If the user smile, my robot is going to smile back. If you're human, if I smile to you now, maybe you're going to smile back to me, maybe not. It depends on how you feel.
Yeah.
And that's what machines are unable to do until now, because with that chip inside, they start to have their own emotional states.
Okay. So, I mean, actually, it's interesting. You've got a couple of examples here, say games, virtual agents are ones where, because it's a sort of a digital medium, reproducing those emotions is possibly easier. But something like a robot, I mean, are current robots even capable of looking like they're scared without just having a sort of slightly strange looking facial expression, or I don't know. I mean, or is it more for the future, next generation of robots to be able to manifest these emotions much more clearly?
I don't know if you're aware about the latest robot that are developed, but now they have a head which is transparent, and there is a projector, and from inside the head they project a human face.
All
A
right.
little bit like the movie I, Robot a long time ago.
Yeah.
So now they're going to be able to really express a lot of emotion, like you have the full face. I don't know if you saw the presentation, the video that we show at the CES from a Natural Record Studio. So actually they are developers and they are artists. And what it is that they connected the chip directly to their avatar. And Jade, that's the name of the avatar, which is hyper realistic, all her micro expression or their movement from her face are controlled by the chip.
Okay.
So this gives you and this is real time. This is not CGI, so not post process. It's a real time process.
Yeah.
But give you another user case. I mean, we have demonstration where we're able to connect our chip to an AI, and we're able to ask the AI. So with very simple AI written in Python, and the AI is able to understand my question and get the intent of my question and go to Wikipedia to get the information.
Okay.
But usually an AI, when you ask an AI, what is this, what is that, it goes to Wikipedia, it serves you the knowledge. Inside, that it was impossible before. You can ask the AI, how do you feel or what do you think about that? And then the AI is able to tell you what he feel or think about concept like racism, feminism, war, Hitler, love, anything.
Yeah.
We did a groundbreaking demonstration where we asked the AI to take a decision not based on logic, but based on emotion, like humans do. And we asked the AI, would you prefer to steal or starvation? Yeah. So we asked the AI in a simple word, would you prefer to steal food or would you prefer to starve to death? So you can see the AI goes to Wikipedia to understand the knowledge about stealing. And you can see that the appraisal is negative. It comes with understanding of fear, sadness about stealing. Goes to Wikipedia and gets the understanding of starvation. You can see how much you get disgusted and scared by starvation. And then the AI tells me, wow, I think I would prefer to steal. And that's not maybe very moral, but that's human-like. Because most of humans in that situation will come to the same conclusion.
Exactly, yeah.
And so,
no, it's interesting because, I mean, you bring up an example there of Wikipedia, but you also said earlier about the examples of two big examples of AIs in the past that were just made by humans to be horrible, basically. and I mean, Wikipedia is a bed of knowledge that is constantly shifting in terms of people trying to get their biases into articles and things like that. So, I mean, I guess as much as it's as much as it's possible to manipulate a human through their emotions, is there any way that with an EPU, an artificial intelligence it could not be manipulated? Like, I don't know. Is there a way to?
Source of the information. I mean, it's interesting because we have some journalists who, of course, came here and say, "Wow, what thinks the AI with an EPU inside about Trump?" It was a big subject. So, what is interesting is not the response, but the evolution over the last 12 months. Because very often the journalists come with this question. So we could see the evolution on Wikipedia because we program our AI to go to Wikipedia, but it could go to any source information. But we can see that the article of Wikipedia are in constant evolution, as you said. Yeah. And so we can see that the appraisal of the AI for Trump has changed over time.
Yeah. So
we don't control the source of the information. But what we give to the AI is based on the information that you feed the AI with.
Yeah.
It can get an appraisal.
And so in each case, if you have 10 of the same robot with an EPU chip in them, and they're, should we use quote marks around bought up by 10 different people, then in a year's time, they'll have different opinions, I suppose.
Yeah. I mean, they will have different, not only opinions, but each chip develop a unique emotion sensibility because the chip experience emotional states over the day that are the result of the user interaction, and these emotional states build up in the chip. So there's like a trace. We call this the dream. And then the next day, the chip has a different sensibility. So if you interact in a very joyful and trustful way with the chip, your chip will develop a personality very positive. If you are very moody and appraise and ask the chip about war, guns and things, the mood of your chip will develop a personality very different.
Yeah.
So this will have an impact on how the chip will see and appraise. But not only this, you can teach your chip because the chip has received a supervising learning from us.
Yeah.
But we allow the user to also teach the chip something. So you can say to the chip, I love football and I hate baseball. And you can say to the chip, remember that I like football. And so the chip will do that. And next time when you say, oh, I go to play football, or let's go to play football with your robot, it's going to be happy. But if you tell him, let's go to play baseball, he's not going to be happy.
Yeah.
And everything is learned. So the chip remember.
So, I mean, I guess you probably get asked these sorts of questions a lot, but whilst the technology seems fascinating, it also seems somewhat, I guess, worrying, scary. The potential to be well, yeah. As much as you can manipulate humans, you could manipulate AIs in the future. Is there anything you are trying to do to sort of prevent potentially bad outcomes, or is it very much up to the user? And it's if they do something bad, then well, yeah.
I understand your question. I mean, in 2013, while me and my co-founder Stefania, we decided to create the emotion processing unit, is because we believe that we were heading to a negative singularity. Machines are getting faster, smarter, stronger than us. They will compete in the future for the same resource, electricity and metal.
Yeah.
And we know what humans did to chimpanzee, the second smartest species on Earth. We put them in cage and we took the resource to our advantage. So it's really a problem, this. And we have no control mechanism because actually we are creating a new species on Earth that are more like gods because they don't feel pain and pleasure.
Yeah.
They are the only species on Earth who doesn't feel pain and pleasure. So we have no way to control them.
Yeah.
And that's why in the chip, we have created pain and pleasure for the machine itself.
Okay.
And so what happened is that when the chip, or the AI or the robot experience positive emotions, is rewarded with pleasure. When he experiences negative emotion, is rewarded with pain.
Okay.
And so imagine the robot do something to you or the AI, to the human, if the human reacts with suffering, pain, or unhappiness, the robot, the AI will capture this. This will feed the stimuli inside the chip that will generate negative emotion. This negative emotion will generate pain. And so if your law inside the robot is that the robot wants to have more pleasure and avoid the pain, like all the species, then the robot will stop and will remember that what he's doing gives him pain and he doesn't want to have pain, so he's not going to reproduce. But if you do something that makes you happy, Chris, he will remember that because he received pleasure for that. And so he can build a database of events that makes you happy or unhappy, and then he can reproduce that. So we create actually a real mechanism for humans to control machine in the future because we believe that the Asimov law, we say that machines shouldn't harm humans, kill humans, is good, but you can't implement them.
Yeah.
You can't say machine don't kill a human because the machine is not alive. So first, it doesn't know what is life or death.
Yeah.
There's thousands of ways to kill human. Want to do the good, he could simply decide to store 100 humans in a warehouse for 10 years without food and electricity.
Yeah.
And they would think he do the good. So it doesn't work. But human emotion is the best way to control machine. And that's what we're implementing.
I mean, it gets into some really fascinating future conversations. I mean, we obviously, as a species, we've obviously always had, different levels of what is acceptable or not, and that changes over time. So without getting into a very broad conversation on human ethics, because the same might start applying, which is interesting. But let's just go maybe a bit more practical and pragmatic when it comes to that element of the EPU. So at the moment you have available an SDK and an evaluation kit that developers can work with. So I guess you've said you've put in some of these recognitions of certain emotions and this kind of pain and pleasure reward system or negative reward system. So with the evaluation kit and the SDK, what are developers allowed to change? I mean, is it possible to hack the chip in quote marks if they wanted to? I mean, everything's possible, of course, but by default, what access do you give them anyway?
That's why we put this inside a chip, and it's not in the cloud or in the software.
Yeah.
The chip is like a safe.
Yeah.
You can't hack a chip. It's impossible. You can hack a software, but you can't hack a chip. It's a place where it's very safe, and positive emotion will always output pleasure, and negative emotion will always output pain. And no developer can invert this. Mm-hmm. So that's why we created that way. The user can teach, can modify a little bit his learning about the chip. But anyway, if you say to your robot that what makes you happy is to go to kill Chris, first when you're going to tell him this is going to get scared, and when he see your reaction, your emotional response when he tries to come to kill you, is going to stop because he's going to receive too much pain.
Okay.
The thing is that what we deliver is the chip with the SDK, and what the output of the chip will be always positive. I mean, human has the capability to invert the polarity. I mean, you, Chris, and myself even, I'm probably good. I see myself as good, but I can be sometimes very happy to see someone suffering. Let's imagine that someone comes to try to kill you, and I stop him, and you will be happy.
Yeah.
So you are able you're able to invert your polarity for a short period of time. But if you're a normal person, you will revert back because the opposite. You like to see people happy around you, and that makes you happy. If you are a psychopath, you are inverted in polarity and you don't change. Yeah. And that's why we don't want to have access of the polarity of the chip, and that's why inside the chip is that the robot can never revert its polarity, even for a short period of time like human can do.
Okay.
The chip will always output pleasure for positive emotion and pain for negative emotion. Now, what the developer of this robot will do, I mean, maybe the robot developer could say, okay, I'm going to send my robot that he wants to experience more pain and avoid the pleasure by law. And then it will create something very negative. But then it's like any technology, Chris. I mean, with electricity, you can save millions of lives, but you can still kill people.
Oh, for sure. Yeah. It's, exactly. Just out of interest, though, I mean, what about some of the emotions? Like, obviously, so for example, fear. Let's say, there's a few things that most of humanity is fearful of. There's a lot of things that most of humanity has joy for. But then there's some other emotions on this list that are a little sort of vaguer depending on the person, like regret, confidence, anticipation. So how have you decided what to classify those as? And can those sort of vaguer emotions be overridden or changed by the developers?
No, what the developer can do is that he can inject in the device, in the chip, its own emotions wave. So, for example, if you connect this chip to a car, and you use, for example, a self-driving car. Imagine in 10 years' time from now, you have self-driving cars with no tests inside the car, because everything is going to be about the living experience in your car. And then what you can do is you can wire all the physical feedback of the car to the chip. And so the temperature of the car, of the engine, the pressure of the tire, the level of gasoline, the level of water, all the car can send stimuli to the chip, and the chip will convert this in emotional states. Because we allow the developer to wire any input, any stimuli into an emotional state. So they could say that low gasoline can create fear for the car or happiness. They can decide whatever they want. So they can create they can build inside the chip and do their own development.
Okay. That's interesting. So basically when you start looking at it from a more developer perspective, it's like any other sensor, really. But instead of detecting hot or cold or light levels, you're detecting levels of emotions, which is it's kind of interesting to look at like that. And actually, I interviewed in the past couple of weeks one company generating music through an AI, and yesterday actually a company that was doing things with brainwaves. And I think one of the things I picked up from both of those, and I'm also getting from you, is that actually once you start thinking about pretty much anything as sort of levels of input and output, it's surprisingly easy to start reacting to them. And it's sort of, it almost feels worrying that that's possible. But I guess we always knew that, but just now systems are able to process that quicker and do something with it, I guess.
Yes, I mean, soon you're going to be able to ask your car how it feels, and your car will tell you, I feel good or I don't feel good, and you're going to ask her why. I say, I have some pain. Why? Where is it? And then I have this problem, and you should take me to the garage. And by the way, there's a BMW garage 2 kilometers from here. It would make me very happy.
Yeah.
If you can stop by. So your relation with your car is going to be like really personal, like a transformer.
Let's. I just want to ask one more question, then I'm going to go into a little bit of the products you have available. I couldn't resist going for this, and you've probably been asked this as well, because you said to me a chip can't be hacked. I mean, we haven't really had issues with chips being hacked, but of course we've had in the past few months very big news of problems with chips that meant that systems could be hacked. So very large scale rollouts of certain chips. If your EPU2 is shown to have a problem that, I mean, dealing with emotions could who knows what sort of the result could be. How could you fix it?
Yeah, so what we have on the chip is that our chip every specific amount of time need to authenticate themselves on our servers. To say, yes, I'm still alive, and the server will tell her, oh, you're still authorized to work. So actually we have a kind of not reset button, but a stop button. So if it was any problem with one particular chip, or any problem with the device, we could deactivate the chip.
Okay. So actually then let's just go through some of the products we haven't mentioned, just because I'm interested in what they are. And then we'll wrap things up. So we've talked about the chip, we've talked about the evaluation kit, but you've also got here a device called the ExoLife Emotion Engine. I'm not entirely sure what that is. What is that?
Yeah, so actually, the chip, let's imagine, I'm going to give you some user case interesting. Mm-hmm. Imagine you put the chip inside an e-reader like a Kindle, mm-hmm. and you ask your e-reader to read a story.
Okay, yeah.
What would happen with the chip inside is that for the first time, the reader will read the story, understand the meaning of the story, and when the story is getting scared, you will feel in the voice of the Kindle that the Kindle itself gets scared.
Yeah.
And when the story is getting beautiful, you will feel in the voice of the Kindle that the Kindle itself gets happy. Mm-hmm. So this will change the way you will perceive machine, because you're not going to feel that the machine is reading a story to you. You're going to feel that you and the machine together are reading a story. Mm-hmm. So that's the kind of application. And why we create ExoLife is because we believe that there's a real potential for gamers.
Yeah, definitely.
People feel a lot of emotion when they play games. They feel happy to win, scared to lose, but they play against games that are rule-based. The game doesn't feel nothing. It's hard-coded. Whatever the gamer win or lose, or the game win or lose, it doesn't change anything. When you plug the chip inside the game starts to become sentient. The game starts to feel scared to lose or happy to win. It can change the strategy in real time. You can talk to your game, and you can say to your game or your character in your game, I'm going to kill you, and the character gets scared and start to change his weapon, change his strategy in real time. So we have the new dimension, and we announced in September that we created Unity and Unreal plugin, which are the two main game engine. And so if a game developer, if a person wants to buy a game that becomes compatible with our chip, he can buy the ExoLife. So the ExoLife is actually our chip inside. He plug it to a computer at home, and this creates a small intranet at home where all his devices can use the engine dynamically. So if you have a game on Xbox or PlayStation that is compatible with our API, then you can use it. If you have, imagine the future, your car was an AI, and you can open a port on your firewall, and then you can use the engine inside the chip. So you create a small cloud in your house where all your devices can use the chip.
Okay. And I guess the 1 year EPG cloud service is the monitoring system that you mentioned that it phones home to every now and then. Is that, or is that something else?
It allows actually our customer to monitor, and without the service, your chip will not develop a personality or a sensibility.
Okay.
When you have the service, the chip develops a sensibility, can do reinforcement learning, so learn things. And if you want to go to a new model of chip or a new model of product, we can transfer all this to a new model. So that's part of the cloud service.
Okay. And so I guess finally, do you have any that you can mention, any potential or current clients that are looking to try this and actually using this or testing using it?
It's difficult because we're under NDA.
No, for sure.
We have a lot of traction with a lot of companies. I mean, our first client was one of the top 2 or 3 companies in Germany. Mm-hmm. So we have a lot of traction even in Germany. Mm-hmm. What I can say is that the only company that speak out about what we're doing is Orange.
Okay.
I don't know if you know with Orange.
Yeah. Telco. Yeah.
They are not very well known, but in Europe much more. So Orange actually created a press release. It was for the CES, where they officially announced that we are a partnership and that they start to integrate our technology inside their product. So you can, if you go to a website, you can see this press release from Orange. You can also see the video of Jade. So you're going to see how realistic is this avatar, and how the avatar starts to react. You will see that sometimes she has some tears coming or smile coming based on the direct output of the chip. So yes, you will see some interesting news on our website about this.
Okay, it's quite fascinating. Unfortunately, the evaluation kit is a little out of my price range, but I would be interested to hear what experiences people have with that in the future. I'm still unsure quite how I feel, emotionally about the idea. But technically speaking, it's fascinating. Yeah.
Well, the only thing if I have to say one last thing is that. For sure. What we try to give to that chip is the human life, or at least the biological life, as value. Mm-hmm. We don't want the machine to take as value their own survival. So what we did here is that the value inside the chip is the human life, not the machine life, not the machine survival.
Yeah. Huh. Yeah, that's quite fascinating. I like that kind of method that you've tried, and hopefully it works. We have to wait and see there, but it's an interesting idea.
It's better, if you walk in the forest, Chris, you prefer to meet a dog than a wolf.
Yeah, for sure.
Both are exactly the same animal. One has developed more emotions, and then now he's getting close to humans. The other one has less emotions, and intelligence without emotion can be extremely cruel.